All right, for the Chapter 3 review, this is the non-calculator part. So we're going to graph each function. Let's just plot 2 nice points. For exponentials, I did 3 in the homework. You can do more than 2 if you want, but I'm just going to do 2. And the asymptote, and then fill in the information. So the parent function is a 3 to the x graph. So the nice points that we're going to start with are 0, 1, 1, 3, and y equals 0. And then these points first get a vertical dilation by a factor of 2. So multiply every y by 2. That makes this 0, 2, and 1, 6. Still y equals 0. And then we're going to go left 4 and down 1. The down 1 will move the horizontal asymptote to negative 1. And then these points here, 0, 2 goes left 4 and down 1. And 1, 6 goes left 4 and down 1. And then we sketch in the graph. So now I can fill in the information. The asymptote equation, it's a horizontal asymptote, so it's y equals negative 1. The domain is all reals just by looking at the graph. The range is negative 1 to infinity. And the x-intercept, maybe if I had plotted negative 1, this might be a nice point, but remember we solved this algebraically, or we can solve this algebraically. We can set this equal to 0. So 2 times 3 to the x plus 4 minus 1. So you can isolate the 3 here, so I'm going to add 1/2. I'm going to add 1 and divide by 2, So that's 3 to the x plus 4. Now for this one, for the x-intercept, I could try changing to log form. So this would be like log base 3 of the result is equal to x plus 4. And then I could solve that. We mostly went the other way. I could put this in my calculator if I wanted. For x-intercept, we mostly went the other way when we had this on a log equation. For the f of x, for the exponential equations, I'm probably not going to put an x-intercept on there, but that is how to find it. So you go from exponential form to log form. And then the y-intercept is when you plug in 0. This I would ask for. So that's 2 times 3 to the 0 plus 4 minus 1. 3 to the 4th is 81. So this is 2 times 81 minus 1. That's 162 minus 1. So 0, 161 is the y-intercept for that one. All right, let's see. For the next 2 graphs, these are log graphs. So the original parent function is log base 2 of x. So those points are 1, 0, and 2, 1, and x equals 0. And then this one has a special case to it, so we can factor a negative, still inside the log, factor a negative out. Excuse me. So this graph has gone through both an x and a y axis reflection. So we're going to do that first. So negative x, negative y makes this negative 1, 0, negative 2, negative 1, x equals 0. And then the graph goes right 4 and up 3. So when you move the x equals 0 line right 4 and up 3, it's at x equals 4. And then plot the point negative 1, 0 and go right 1, 2, 3, 4 and up 1, 2, 3. Negative 2, negative 1, go right 1, 2, 3, 4 and up 1, 2, 3. So I have something like this. The asymptote equation is x equals 4. The domain for this one, just take a look at your graph here. It's negative infinity to 4. That's also setting 4 minus x greater than 0 in solving. The range is all reals. The x-intercept, I'm not seeing it, so I'm going to solve for it. Now, we did do this in the homework and on a worksheet a time or two here. So this I will ask you about. So isolate the log, and you want it to be positive, so I'm going to add the log over to this side. Now write in exponential form. So write this equation from log form to exponential form. So that's 2 to the third equals the result, which is 4 minus x. So 8 minus 4 is 4, but that equals negative x. So negative 4 equals x. For the y-intercept, that's plugging in 0 into the log equation. So f of 0 would equal negative log base 2 of 4 minus 0 plus 3. So what's the log base 2 of 4? That's 2, right? And there's a negative sign out in front. So f of 0 is 1. So actually, I could plot those 2 points if I wanted to have even more here. That's kind of nice. And negative 4, if I want to be even more accurate, that's really what that graph looks like. All right. Get that off of there. So the third graph is a log base 6. Let me do this down here. Y equals log base 6x. So the original points are 1, 0, and 6, 1, and x equals 0. And then there's a 2 in front of the x and a 4 on the outside. So every x gets divided by 2, and every y gets multiplied by 4. So this becomes 1/2 0 and 3, 4. Divide 0 by 2, you still get x equals 0. And then there's been a shift of down 1. So shifting x equals 0 down 1 doesn't do anything. So we're still at x equals 0. Then plot 1/2 0 and go down 1. And plot 3, 4, but go down 1. This is a log graph. So it has this general curvature. So x equals 0 is the asymptote. The domain is 0 to infinity. I'm just getting that from the graph. The range is all reals. The x-intercept, I can't quite see what it is, so I'm going to solve for that. So set this equation equal to 0. Get the log by itself. So this time I'm going to add 1 over to keep the log positive. Divide by 4. So you get the log by itself, no numbers in front of it, no numbers being multiplied out in front or added out in front. So change this to exponential form. 6 to the 1/4 equals 2x. So whatever the 4th root of 6 is divided by 2, that's our x value. We're not going to worry about plotting that. The y-intercept is when we plug in 0. So that's 4 log base 6 of 0 equal minus 1. You can't log 0. There's also a vertical asymptote on the y-axis, so no solution for the y-intercept. All right, I'm going to do one more page, and then I'm out of time, so I'll have to do another video for the second part. Evaluate and simplify. So this is throwing all of your properties together. So you're thinking, evaluate with exponents, or what are the properties, or what are all of our rules. So we've had this again in a couple of homeworks and worksheets now. You should circle anything that you're having that you're not quite sure on, or that you had to really look up to double check the answer. And then go back through the other worksheets and see if you can find problems similar to that. Or make sure you ask about them in office hours. Okay. Natural log of e to the 4th is 4. Natural log of e to the 1, natural log of 1 over e to the 5th is negative 5. So minus negative 5. Because remember, you're saying what power is on e. Natural log of 1 is always 0 because e to the 0 is 1. So this becomes 4 plus 5 plus 0, so 9. For this next one, be careful with this canceling property here. This is not 3 plus 4. You have to condense first. So you have to make this e to the natural log of, to condense these two natural logs, you multiply their insides. So e to the natural log of 12, and then you can cancel, and the answer is 12. So it's illegal. It's not correct. It's not the right property to say cancel 3 plus 4. I can't individually evaluate these because the bases don't work nicely with the results. So I'm going to do change of base first. Change of base says turn these into fractions, log of 9 over log of 5. And this one's log of 25 over log of 9. Cancel out. Something should always cancel the way I've designed these problems. So the log 9s cancel. So that leaves you with log of 25 over log of 5. Now you're not finished. Reverse change of base. What do I mean by that? I can't reduce 25 over 5. I can't cancel the word log, but I can make this log base 5 of 25. That's change of base, just going backwards. And that answer is 2 because 5 squared is 25. Natural log of 7 over natural log of 49. Again, this is reverse change of base. Anytime you see a ratio or a fraction with logs in it, it's reverse change of base. You are not allowed to reduce 7 over 49 or cancel out the word natural log. So that means this is the log. The base is 49 and the result is 7. So 49 to what power is 7? 49 to the 1/2 is 7 because square root of 49 is 7. All right, what about this one? 32 has a square root. It's the square root of 32 to the 4th. So I guess you could make that, if you wanted to, you could make that 32 squared, right? This is the same as, there are a few ways to tackle this one, I guess. 32 to the 4th to the 1/2 power. So let's start there. This is the same as square root of 32 to the 4th is the same as 32 squared. Now, do I want you to find 32 squared? No. I would rather that you use your your logarithm expanding rules. Pull the 2 out in front. Evaluate log base 2 of 32. That's 5. And then multiply that answer by 2. This simplifies to 10. For this one, 5 to a power is not 100. 5 to a power is not 5. Not a nice power anyway. So we should condense first. This becomes log base 5 of 100 divided by 4, which is log base 5 of 25, which we've had before. That's equal to 2. Natural log of e is 1. Natural log of 1 is 0. Log of 1 is 0. So my answer is 1. Remember not to overthink this. This is base 10 here. Count the zeros. 3, 6, 9. So this is saying what's the log of 10 to the 9th plus the log of 10 to the 4th. That's 9 plus 4, which is 13. I can't quite read what this says. I think this says natural log, e to the natural log of e to the 5th. So you can cancel out the e to the natural log, and you're left with e to the 5th. All right, true or false? Now this is usually like, can you condense one side or the other and get it to match the other side? Or can you expand one side or the other and get it to match the other side? So let's take a look here. This side could have been, if I said condense this side, then that would be natural log of x divided by y, which is not the same as natural log x divided by natural log y. This is change of base. So this is false. For the next one, let's expand this side. Or you could condense this side, whatever. Natural log of x plus natural log of y, which is equal to what we have. Equal to natural log y plus natural log x. So that's true. What about this side? Maybe we work on the right side here. Let's expand this. we'd have a 1/4 log base 4 of xy. And then we can expand that into 1/4 log base 4 of x plus log base 4 of y. Now, I'm showing you all this work, by the way. You're just answering true or false for your quiz or test. You can do work for yourself, but there's not a required amount of work for these. That is equivalent. Multiplying something by 1/4 is the same as, oh, sorry, I've been saying base 4, base A. Base A. That's the same as log base A of x plus log base A of y. Instead of multiplying that by 1/4, that's the same as dividing by 4. So this is true. For the next one, there is no way to expand an x plus y or an x minus y in a logarithm. On this side, if I were to condense this, it would be natural log of xy. So that's not equivalent to natural log of x plus y. So false. I think the true or false section is always the hardest to wrap your brain around. Let's see. So here we have, let's expand this side. There's a big 1/2. And then we have natural log of x plus natural log of z minus natural log of y. Is that equivalent to what's out here? They have a 1/2. They have it in different orders, but the plus and minus signs are right. ln x minus ln y plus ln z. That's fine. So that's true. If log base a of x equals log base b of y, then x equals y. This one's false because the bases need to match. It's only true if they're both base a or both base b. All right, what about this one? Let's expand. The log base a of a minus the log base a of b. Is that equal to 1 minus log base a of b? So where did that 1 come from? Remember here, a to what power equals a? That does simplify to 1. So yes, this is true. Last one of these, I think. Is there more in the next page? No, yeah, last one of these. Natural log of x minus y is not the same as this. I tried to kind of trick you with this in number 13 too. So this side you can't expand. And this is change of base. So this is equal to log base y of x, but that's not the same. So this is false. All right, I'm going to stop this video here because I'm out of time this morning. I will pick up on the second video a little bit later.